This is a video from Math 386, and the directions say to prove the identity. Okay, so what we're going to do is we're going to take a look at the first example. Suppose I ask you to take sine of x plus cosine x and square it. And the claim is that that's equal to 1 plus sine of 2x. Okay, so what we want to ask ourselves is which side looks harder? And I would venture to say the left side looks harder. And so what I'm going to do is I'm going to start with sine x plus cosine x squared. But that's equal to sine of x plus cosine x multiplied by sine of x plus cosine x. Now, if we FOIL this out, we get sine squared x, so that's sine x times sine x, plus sine of x cosine x, that's this one, plus sine of x cosine x, plus cosine squared x. Now, if I take sine squared x and I add cosine squared x, I get 1 back. And so this is 1 plus 2 sine of x cosine of x. But this is equal to 1 plus sine of 2x. And that's what we wanted to show. So, therefore, if I take sine of x plus cosine of x and I square it, I get 1 plus sine of 2x. And that's how we do example 1. Let's take a look at example 2. Suppose we wanted to show that cotangent squared x plus secant squared x equals tangent squared x plus cosecant squared x. Now, this one's a really, really, really good problem, okay? Because if I take 1 plus cotangent squared x, we get cosecant squared x. But what I want to do is I want to solve for cotangent squared x. So I'm going to subtract 1 on both sides, and I'm going to notice that cotangent squared x is cosecant squared x minus 1. That's for starters. So in case you hadn't realized, we're going to start with the left-hand side. Now, 1 plus tangent squared x. Well, that's equal to secant squared x. And we're okay there, right? And so, therefore, if I take cotangent squared x and I add secant squared x, this is equal to cosecant squared x minus 1, right? So in other words, I'm just replacing cotangent squared x with cosecant squared x minus 1. Then I'm going to go plus, and then I'm going to replace secant squared x with 1 plus tangent squared x. Now, notice the minus 1 cancels out the plus 1, right? Because negative 1 plus 1 is 0. And what we have is tangent squared x. So I'm just going to write this term first because that's what's on the right-hand side here. And then I go plus cosecant squared x. And we're okay. Therefore, cotangent squared x plus secant squared x is tangent squared x plus cosecant squared of x. And that's how we do example 2. Let's take a look at example 3. So in example 3, we have the following. We have sine squared x minus sine squared y on the left side. On the right side, we have sine of x plus y times sine of x minus y. Now, believe it or not, I'm going to start with the right-hand side this time. So I'm going to take sine of x plus y, and I'm going to multiply it by sine of x minus y. So this is sine x times cosine y plus sine of y times cosine x. That's the first factor here. The second factor will be sine x cosine y minus sine of y cosine x. Now, when I put this together here, I'm going to get sine squared x cosine squared y. Then I'm going to go minus. Then I'm going to get sine squared y cosine squared of x. Like so. Okay? Now, couple of comments. Now, remember, we started with the right-hand side, and we're trying to arrive over to the left-hand side. And in trying to arrive over to the left-hand side, I want you to notice, well, I don't see any cosine squared y's or cosine squared x's, right? So what do we do with that? Well, there's a couple of ideas that I have in mind. So I'm going to take sine squared y, and I'm going to multiply by 1 minus sine squared y. Then I'm going to go minus sine squared y times 1 minus sine squared of x. Like so. And so this is equal to sine squared x minus sine squared x sine squared y. So all I'm doing is distributing, right? I'm taking the sine squared x times the 1 and the sine squared x times the sine squared y. Okay, then I'm going to go minus sine squared y plus, and if you notice, a negative times a negative is a positive, right? And so I'm going to get sine squared x times sine squared y. But notice how I can cancel out these two terms. And what I have left is sine squared x minus sine squared y. And that's what I wanted to show. And so, in other words, if I take sine squared x minus sine squared y, this is sine of x plus y times sine of x minus y. And we're good. Now, a couple of comments, right? Notice how I'm starting from the right side. I'm trying to get to the left side. And we have an identity for sine of x plus y and sine of x minus y, right? But I noticed really quickly when I expanded that out, right? There's a couple things that we want to keep in mind, right? When I look at the left-hand side, I don't see any cosines involved. But I know that there's a relationship between cosine squared y and sine squared y. And that's what I tried to take advantage of. Same thing over here. There's a relationship between cosine squared x and sine squared x. And so notice how that's what I have inside the parentheses here for both. And then once I applied the distributive property, I noticed how those terms cancel, and we get what we have left. So it takes time, you guys. It takes practice. Okay, so with that in mind, let's take a look at this one. We'll call this example 4. And we get the following. Tangent of x plus y equals sine of x plus y divided by cosine x times cosine y. Now, in my opinion, the right side looks harder, right? So I'm going to start with the right-hand side. You always go for the side that looks harder. And so I get sine of x plus y divided by cosine x times cosine y. Okay. From here, I'm thinking, okay, I could expand out the numerator into sine x times cosine y plus sine of y times cosine x. And I'm going to divide by cosine x times cosine y. And then what's your gut reaction? My gut reaction is I want to split the fraction. So this is sine x times cosine y divided by cosine x times cosine y. Okay? Plus. Oh, and then one quick correction here, by the way. This, on the left-hand side, we should have tangent x plus tangent y. Sorry, just one quick correction there. Now, over here, we have sine of y times cosine x divided by cosine y times cosine x. But if I look at sine x over cosine x, that's tangent x, right? But the cosine y's cancel, then I'm going to go plus, the cosine x's cancel, and we get tangent y. And we're done. So that implies tangent x plus tangent y is sine of x plus y divided by cosine x times cosine y. That's example 4. Let's take a look at example 5. In example 5, we have the following. So, suppose I give you this one. I'm going to give you okay, so we'll do tangent squared x minus sine squared x. That's the left side. On the right side, we get tangent squared x times sine squared x. So which side looks harder is going to be the question. And I would probably say I would look at the left side. So in other words, I'm going to look at tangent squared x minus sine squared x. Okay? And this is where you got to get in the habit of we try stuff, right? So it's kind of a couple of options we can do, all right? So tangent squared x is sine squared x over cosine squared x minus sine squared x divided by 1. Now, what is a common denominator between cosine squared x and 1? And I would say that it's going to be cosine squared x. And so I have to take the second term and multiply the numerator and denominator by cosine squared x, just like this. Okay? Now, from here, I'm going to get sine squared x minus sine squared x times cosine squared x divided by cosine squared x. It's really, really good problem. It's really interesting because now look what happens. In the numerator up here, I'm going to factor out a sine squared x. In parentheses, I get 1 minus cosine squared x. And then on purpose, notice where I'm placing the cosine squared x. And I want you to pay attention to something here. What is sine squared x over cosine squared x? Sine squared x over cosine squared x is tangent squared x. And then I'm going to go times, what is 1 minus cosine squared x? 1 minus cosine squared x is sine squared x. I'm done. And so, therefore, tangent squared x minus sine squared x is tangent squared x multiplied by sine squared x. And that's example 5. Let's see if we can do one more for this video here. Let's call this example 6. And in example 6, we have the following. Okay, so let's do this one. So sine x times sine 2x plus cosine x times cosine 2x. Okay? Now, let's see if we can recall something. Recall. Because we have to practice going backwards. So if we have cosine of a plus, we're going to make that a minus b. This is cosine a times cosine b. We're going to go plus sine of a times sine of b. So we have to view this in a very specific kind of way. So, and by the way, on the other side, we're trying to show that this is equal to cosine x. So the left side is absolutely harder, right? So I'm going to take sine of x times sine of 2x plus cosine x times cosine 2x. But I'm going to view this in just the right way. So this is cosine 2x times cosine x plus sine of 2x times sine of x. But this is equal to cosine of 2x minus x because of that formula up here, right? And isn't 2x minus x, x? So this is cosine of x. Therefore, sine of x times sine of 2x plus cosine x times cosine 2x is equal to cosine x. And that'll conclude this video for Math 386. It's on verifying trig identities, and we looked at 6 different examples. Okay, all right, thank you.